Welcome to Unit 3, Lesson 6, Rational Equations, Part 2. Now let's write and solve some rational equations from context. Let's carefully read a situation like this. Noah likes to go for a boat ride along a river with his family. In still water, the boat travels about 8 kilometers per hour. So we're given a speed. We got to figure out that. In the river, it takes the same amount of time to go upstream distance than it does go downstream another distance. Okay, so we got stuff going on here. So what you want to do basically is draw a little picture. So if you're in a boat, and let's say up is upstream, you're going 5 kilometers, which is a distance, and you're in a boat, and you go downstream, you're going 10 kilometers, which is another distance. So something must be changing, going up and downstream. Well, obviously it's the current. So we got a distance, we got a speed of 8 kilometers per hour. Speed, distance, and time. So this is speed, distance, and time. Now we got to do is figure out how they relate to each other and how to use them. So I'm not going to solve anything here, but this one is to get us to think about what we need and what's going on in this situation. Okay, let's look at this problem. It's the same problem as the warm-up. So let's look at our next problem here. All right, it's the same problem from before, but now let's write the equation. So in still water, how long would it take d kilometers to travel in the boat? So how long would it take? What we're looking for here is time. So we have speed, distance, and time. Speed, distance, and time. How do they relate? We know that speed is distance over time. But if we do like this and make a circle out of it, this line always means divide. This line always means multiply. All right, let's put these lines in different colors. So divide in purple and multiply in blue. All right, maybe that might change some things. Okay, so time equals distance over speed. Our distance is 8. No, our distance is d, little d. Our speed is 8. So it's just d over 8. If the speed of the river is r, write an expression for the time. So we need to write an expression. So what we do is we're going upstream is against the current. So time going upstream is distance 5 over 8 minus the current of the river. And then time downstream is 10, 8 plus the current of the river, because you're going downstream. They tell us that it takes the same amount of time to go upstream as it does downstream. So if we set these equal to one another, then we can solve for r and figure out how fast the river is going. And then we solve this by cross multiplying or using the butterfly method. So we're going to cross multiply or the butterfly, which is the same thing. Basically, you're multiplying here, you're multiplying there. Same thing. All right, so what we in essence have is 5 times 8 plus r equals to 10 and 8 minus r. And then we solve from there. We're going to solve this on the next page. Remember, when a number is next to a group, we have to distribute And we get 40 plus 5r equals 80 minus 10r. And like I said before, we're going to finish this on the next page. Okay, now we're looking at the same problem. Speed. What is speed? Speed is distance over time. How long would it take? That's time. So, time equals distance over speed. So, time, what's our distance? How long would it take to travel d kilometers in the boat? So d, our speed is 8, that's time, d over 8, because that's what we're given in the problem for this situation. All right, now for number 2. If the speed of the river is r, so now our speed is r, write an expression it takes to travel 5 kilometers upstream. So 5 over 8 minus r equals time, because time is distance over speed from the previous equation. So this is time upstream. I'm going to put a subscript u. Now, time downstream, let's put this in a different color. Time downstream is the distance divided by the speed, 8 plus r, because we're with the current. Against the current, with the current. And from here, we have 2 separate equations. Now we got to solve for r. So now use your expression to calculate the speed of the river. So if we set them equal to one another, we can solve for r. So just like before in the previous one, we cross multiply. 5 times 8 plus r equals 10 times 8 minus r. You get 40 plus 5r equals 80 minus 10r. We add 10 to both sides, 10r. Okay, I just rewrote it on the next page. So we got 40 plus 15r equals 80. I subtract 40 from both sides. 15r equals 40. If I divide this by 15, I'm going to leave the answer as a fraction. I am going to divide 5 out. I get 8 over 3, which is what? 2 2/3. So r is about 8/3 kilometers per hour. And you can get the decimal if you want, but I'm going to just leave it like this. This problem is for anybody interested in going into software or electronics or electrical engineering or something like that. Maybe some of you electricians. Okay, so what we have here is the total resistance law given in this equation. This is for calculating total resistance in a circuit. So this is how this works. You got to flip it over and then flip it back up to get the resistance. Let's look at problem number 1. 2 circuits are in parallel. So to get the resistance, we do 1 over RT equals 1 over R1. The first circuit has a resistance of 40. The second circuit has a resistance of 60. Well, what's the one thing we know? We cannot add fractions with different denominators or different bottoms. So the bottoms must be the same. So we have to run through our multiples of 40 and 60. So I'm going to do that up here in red. So 40 times 1, 40 times 2, 40 times 3, 40 times, oh, that's 120, I'm sorry. Let me make that neater, that's 120, because I was thinking 3. And then we list the multiples of 60. And look, we have a match, 120. So 1 over 40 times 3 over 3 equals 3 over 120. And 1 over 60 times 2 over 2 gives us 2 over 120. Now that the fractions have like bottoms, the same bottom, we can add them. 2 plus 3 over 120 equals 5 over 120. Okay, so 1 over RT equals 5 over 120. So RT equals 120 over 5, which gives us 24. And the resistance is ohms, by the Greek letter omega or ohms. And that's the unit of measurement for resistance in a circuit. Okay, let's look at problem number 2. The second circuit has a resistance of 150 more than the first. Okay, so for problem 2, basically what you do here is just go 1 over RT is 150 more than the first. So for the first must be 1 over R, whatever the resistance is, plus the second circuit is R plus 150. We don't know what R is. They're not asking us to solve for it, so this is all we have to do. Okay, for this problem, it says for this circuit. Now, this is where the words get tricky. For this circuit, which is referring to the circuit above, Claire wants to use graphs to estimate if the resistance of the first circuit R, if RT is 85 ohms, 1 over RT is 85 ohms. So 1 over RT equals 1 over 85. And then the other side of it is 1 over R1 plus 1 over R2, which was R plus 1 over R plus 150, because they had the same resistance, equals 1 over 85 for the total resistance. And so now what we do is graph both of these. Graph this one. If y is equal to y, you set y1 equal to this one. You set y2 equal to this. And then get the points of intersection. Where, at what x value are both y's the same? You see, so 1 over 85 is going to be a flat line, a horizontal line. And the next one is going to be some type of curve. And they'll intersect somewhere. I don't know, but they will. You'll graph it and you'll find that. That's what you're looking for. Put these in. Put that one in the y1, 1 over 85. Put the second half of the equation in the y2. And you should find a number. It should be about 123 ohms. Well, you won't have ohms in the calculator. You'll just have numbers. So somewhere around 123. That's what you should see.